Hello, everyone. Welcome back. This is one of your friend, your DevOps guide, Ritik Saini, and today I have a great project for you. So basically, this is a project where we are deploying a Netflix clone, and we would be building the entire CI/CD pipeline in order to automate the entire process. Initially, I would show you how to deploy it locally, and then I would show you how to do it using Jenkins. So what we are doing is we have a Jenkins server for our pipeline, and then we are using SonarQube in order to do the static code analysis, and then the dependency check is done by OWASP. Trivy scan is used to scan the file system locally, and we can also use it to scan our Docker images. And then we are using Docker in order to deploy our containers using Kubernetes. So this entire architecture would be monitored by Grafana and Prometheus. And we also would be integrating this with Gmail. So whenever our job fails or succeed, it would notify us on our Gmail account, and our repository is on GitHub. That's how we are deploying entirely. So I'd show you. Initially, I'm deploying 90% of my infrastructure using Terraform. So what I'm doing out here is I'm deploying a VPC, a subnet, security group, and also Elastic Compute Cloud. So that would be a virtual machine, and we would be using here, as you can see, we have some data blocks where we are fetching the availability zone regions and also the Ubuntu AWS Ubuntu image ID. So we would be referring this later while when we would be deploying our EC2 instance and using this data which we have fetched into our resource block. So as you can see, we have some. I'd show you the providers that I'm using. I'm using AWS as provider and local in order to manipulate and like whatever modification we have to do to our local files which are present in the local machine. And then we have one more provider which is TLS. This is used for generating the SSH keys. And out here, as you can see, I'm not using backend. Like I'm not using a local backend. I'm out here using a remote backend which is on S3. And in order to use S3 as a remote backend, it doesn't really support state locking. So in order to support state locking, we have a provisioning where we actually have to deploy a DynamoDB table. So DynamoDB is a key pair database, key value database, and that's how we actually save our JSON formatted state file. So whenever a person is making any changes or modifying the infrastructure that we have, the state, there is a provision from Terraform which helps not to actually make multiple changes to the same infrastructure simultaneously. So that would end up in resulting a lot of errors, and that would really mess up the current environment that we would be having if two-person like straight away make any changes or apply any changes to the infrastructure. So in order to not to do that, Terraform gave us state locking. So that's how we are using state locking out here. We already deployed a bucket, and then we are using the key and the region, and the DynamoDB table that we used or like launched was Terraform dot hyphen logs, and then encryption is enabled true. So I'll show you how we can like deploy DynamoDB table and also do state locking on it. So let me just show you right now. Just give me a second. So out here, let me reach out to S3 first. So as you can see out here, there is a bucket that I've launched. So I launched this bucket from Terraform only. So I'll show you the code for launching the bucket later. But yeah, that was the bucket which I launched. And here I already had one state file saved because I ran it earlier for my own try running purposes. So I would be showing you the DynamoDB table now and how we actually launch it and integrate it with S3 bucket. Just give me a second. So we would be using the table name as Terraform logs. Partition key would be lock ID, that is in capital. and rest of the things are just as it is. And we create this thingy, create the table, and once this is created, we can use this backend configuration without any errors. So let me go back to the main file again. Oh, the EC2 deploy, there it is. So I was using local resource or local plugin in order to manipulate my file locally, and then this is a locals block, by the way. Sorry, this is not the provider that I'm using. This is the locals block, where I'm defining some variables which I would be using quite often in my configuration file. So this helps us simplifying our configuration file. So out here we are deploying a VPC, we are deploying a public subnet into the VPC, and then we are also deploying a public route table in order to divert or like basically forward our traffic from the internet to where we want to divert it to inside our infrastructure. Okay, and then we are what we are doing is from the internet, if there is anything, it first has to reach to the internet gateway. So internet gateway is deployed out here. Internet gateway, through the internet gateway, further we have some routing table or routing rules that we have mentioned. So anything from the internet, it should be reaching out to the gateway, and then from the gateway, it should be reaching out to the public subnet or the VPC that we have. So this is the VPC ID where our traffic would be diverted to, and then inside a VPC we have subnets. So this is a public subnet association, and then uh, here I have deployed a security group. So we are using this security group rule in order to ping our VPC uh, environment that we have. And then we generated, this is a provider that we used and installed in our configuration file, terraform.tf. And using TLS private key, we're generating a key, and then using locals plugin, we are manipulating that key onto our system and giving the permissions, and then using AWS key pair, we are actually uploading the key pair to AWS. And later on, we would be associating this key pair to our EC2 instance so that whenever we want to access our EC2 instance, we can use that key pair in order to access it. And then out here, I have mentioned a security group for SSHing into our machine. This is called, the security group name is called ingress-ssh. And then I have some security groups for my VPC web. So basically out here, this is a security group that I would be associating to my EC2 instance in order to allow the exact rules for diverting the traffic from the internet to where I want to. ATS for HTTP, 8080 is for Jenkins, 443 is for HTTPS, 8081 is for our application, and then 9000 is for SonarQube, and then these are the ingress rule, and the egress rule would be anything from within the VPC or like whatever we have from inside can reach out to the internet without any uh, without any obstruction. To be honest, right now we are just like, we are providing the main security in the inbound, and we are just letting the outbound flow from inside our VPC. So then after this, we are deploying our web server. So this is a web server, and this is the ID that we fetched using the data block which we used earlier in order to fetch the Ubuntu ID. And then we are using T2 large out here, and also the subnet ID would be this. So the EC2 instance would be launched in the public subnet, which is public subnet 1, and we are fetching the ID and doing that. And then the security groups that I created, all of these 3 security groups I have associated with my EC2 instance. And then, so this is a key name which I associated, and the connection would be using this block. So this basically binds our SSH key with our EC2 instance so that we can use it in order to access it. And then we are launching an EBS block. So out here we would be using the size 25 GB. Reason, because we would be installing a lot of different services and softwares in order to make this project happen, right? So we need quite a little bit more space. So by default it is 20, set to 20, but we are using 25 GBs out here. And also, we are attaching an elastic IP with our instance. So you may ask why Elastic IP? Elastic IP, basically, I'm using that in order to keep my IP static. I mean, I don't really want it to change, so that's why I'm using an Elastic IP, so that even when I restart the server, usually your IP changes. But once you use or attach Elastic IP with the EC2 instance, no matter how many times you restart it, the IP would be constant no matter what. So let's see. Before deploying this code, we ran Terraform. We ran some Terraform commands, and those commands were Terraform init and then Terraform format. Terraform init basically initializes our directory and install all the plugins and all of the things which are required in order to run this environment in Terraform. And then also it also loads the command that we would be using later in our infrastructure. So one of the commands are like format fmt. This formats are configuration file within the same directory, and also validate. This validates a syntax. If there is any syntax error, it would define us. And then we use Terraform plan. Terraform plan would give us an overview of how our infrastructure would be looking. So this helps us in order to identify how in order to dry run our infrastructure. And as you can see, okay. Oh, I didn't save it, right? So let me just save it once. Whenever you run any configuration, always remember to save your configuration files first, and then uh, do Terraform apply or Terraform init. So I would be running the commands again, Terraform init. Oh, by the way, I'm not in the right directory. So sorry about that. So we would be switching our directory from the practice to EC2 deploy. Let's go. And ls, yeah, perfect. So we would be doing Terraform init. As you can see, we were successfully able to configure our S3 backend, and we are now installing the providers plugin, which we mentioned in our terraform.tf file. So let's wait for that. So by the time I can show you my AWS environment, right? So out here, as you can see, EC2. You can see there are no EC2 instances running right now, and also that's weird because I had some instances launched earlier, but it's not showing. Yeah, that's why. Sorry about that. We were not in the right region. So initially we were in California, US West 1, but I deployed some instances in US East 1. So here, as you can see, there are some instances that I launched earlier for a different project, but you can't see any of the servers running right now. So after I would be doing Terraform apply, you can see some configuration deployed on my AWS account. So we ran Terraform init. Now we would be running Terraform format in order to format if there is any format error. So everything is sorted. Terraform validate in order to check the syntax error or anything that we have. So everything is clean. So out here, then we would be running Terraform plan. And let's see how many changes would be applied. Yep. So there are 15 changes that needs to be applied, and there are no errors into it. If there was some error, dependency, if there was some error related to the things that I'm deploying, and there are some configurational error, plan can actually help us find that out. And now I would be using Terraform apply. You can use auto approve in order to straight away approve it, but I'll just show you apply. It would show what the changes would be happening in my infrastructure and what would be deployed. And once it shows that, it will ask me to enter yes or no. So only yes would be approved as like an input. So out here I type yes, and let's see what happens. I'll just close the other things out here. Terraform EC2. As you can see, we have a key, and I think there would be an error for stating that the key already exists, so you don't really need to do that. So it would just give me an error. So it's okay. I already have the key uploaded, so everything would be deployed. But oh, everything is perfect then. Cool. Yeah, because I deleted the key, I guess. Yeah. So we have our lock. So this is the lock that I was talking about. So every this thing would be updated into my S3 bucket. So let me show you quickly my S3 bucket first. Our state would be updated. So let me show you production, AWS infra. I could show you the time that it was updated. Just give me a second. This is a file that was updated, and as you can see, yeah, today's 16th of December, and the time was 1846. And if you want to see it, I can show it to you. And here's our state file. So this state file contains everything that we have deployed using our configuration file. That's the beauty of it. So we are using S3 as a remote backend, and then let me show you the EC2 instance. I'll just show you the entire VPC cloud first. Let me go back to VPC. Okay. So as you can see, there is a demo VPC out here, and I can show you an overview. I have two public subnets, and then I launched the EC2 instance of the public subnet 1. So let me reach out to the EC2 instance now. Here is our EC2 instance that we would be using in order to run our application and install the dependencies and everything. So as you can see, I want to show the subnet in which my EC2 instance is networking. Subnet ID, public subnet 1. There you go. This is the subnet that we launched. So as you can see, like this instance got deployed in the in the public subnet that we deployed via our infrastructure. So everything is out here, and we would be moving to the next step of installing Jenkins and all the required things that we would be installing in our EC2 instance in order to deploy the entire code of Netflix clone. So as you can see, I connected my EC2 instance. So there would be a couple of things that I would be directly referring, not a couple, everything I would be referring is from my README file that I showed out here. So initially we launched it, we cloned the I would be skipping this part in order to run the application locally because this is quite easy. And I need you guys to do one thing. You have to access the TMDB website, and then you have to generate an API token in order to use this as the database for connecting to our Netflix clone. So what it does is like TMDB provides a database for all the movies which are present over the internet, and then we can use the API in order to connect it to our application so that our application can then fetch the data from TMDB in order to show whatever we want to see. So as you can see, I right now in the midst of deploying my application. So I would just mention the URL. That would be yes. Let me just show it to you. Just give me a second. Our application is running on port 8081. So after entering all the details over here, as you can see, there would be an API key. I'm not showing it to you guys right now. Oh, there is also read token out here. But yeah, we would be using the API key and we would be referring this. So it's okay. I would be deleting this key later. So let's not worry about it. So these are the steps that I would be following right now. So let me clone the repo first. And we clone the repository, and then we would be installing Docker. Just copy this and then Control Shift V. This would install Docker and it would also give the essential required permissions in order to use Docker. And then we would be deploying our application. So in order to deploy our application, we actually need to, I'll just show the Docker file to you first. So here's our Docker file. And over here we are using multi-stage Docker build. And out here we are setting some environment variables. So one of the environment variable is the key, the API key that we'll be mentioning. So in order to deploy our application, providing an API key is very essential. So that's why in my README file, we are actually deploying the container or the application. Once we build the image, we are deploying that image using the API key that we would be having. So I would actually just copy this first. So just copy paste. Here we are using Docker build in order to build our application with what happened. Let me just have a look at it. So initially we would be changing. So hi everyone. So let me get back to you. There was an error, so which I resolved. So let me get back to you over here. So let's initially what I was explaining was like, yeah, you have to copy an API key, which you would be generating after logging in into the TMDB database. And then you have to build the image using this API key when you're launching the container. As you can see out here, build Docker image using the TMDB v3 API key and pasting your API key and then deploying or like building the image. Why are we doing that? We are doing that because we are actually using these argument into our Docker file when we are deploying the application. So as you can see, here is the API key that we would be referring, but we need this API key in order to build this image, else it would result in an error. So that's what we did out here. I can show the code to you. I would be building the Netflix image using my API token over here. Let's copy this token and paste it out here. And let's build our image. So as you can see, our image has been successfully built. So you can see Docker images in order to list the image. And here is our Netflix image that we are using. As you can see, it is merely of 58 MBs. That's the beauty of multi-stage Docker build. And now we would be running the Docker image using Docker run. And you can also just copy the code from here. Docker run Netflix port would be 8081 on Nginx server. So that would be mapped to 80. And over here, you can just paste it. So as you can see, our container is running now. You can access the container on port 88, 8081. So just copy the public IP and paste it over here, and then 8081. And there you go, voila. Our container is running and our application is perfectly running fine. So let's see whether it's playing or not. Oh yeah, definitely you can see that. Everything is playing and our application has been successfully deployed. So let me get back to you and stop the container for now. How can we do that? first of all, we have to list the containers that we are using. We have to copy the container ID. Sorry about that. Oh, copy the ID, and then we use docker stop and just paste the ID. And then we would also do docker remove, and then we would remove the container, and everything is done. I would also actually clean up, I would also want to remove the image. So docker images, I think, here it is. So docker RMI straight away. Let me just copy it from here. We would copy the image ID and copy and paste. So everything is done now. So let's clear all this. Our one fourth of the segment is complete where I deployed the infrastructure and we locally deployed the Docker container. Now, what we would be doing is we would want to install Jenkins in order to make this entire process automatic and deploy it using Kubernetes. So how can we do that? So we would first install some softwares which are used in order to do the scanning part. This is the security segment which is managed by SonarQube and Trivy, and we would also use OWASP for our dependency check. And I'll just show it to you how you can download it and use it. So initially we are just launching the Sonar server as a Docker container. So that's what we would be doing out here. So let's just go back and deploy our SonarQube server. As you can see, we are able to do that quite easily. And then we can access the SonarQube server on port 9000. That's where the SonarQube runs locally. And just give me a second. So everything has been pulled, and so as you can see, like Docker run also fetched the image and also it launched the container. So I can again copy the image ID and then, oh sorry, public IP, and then copy it out here and then like mention port 9000 on it. So as you can see, we are successfully able to log in into the SonarQube server and just wait for a couple of seconds out here. And by the time we can actually install Trivy, we can install Trivy using the script. And Trivy is basically used for file system scanning or a Docker image scanning. We can do all those things using Trivy. So let's copy and install, provide the required arguments, and everything is, just give me a second. So everything is done now. So let's get back to the Netflix repo that we had. So Trivy can be used in order to scan the file system. So Trivy fs, and then this is the command for scanning our current repository, which is the Netflix clone. So let's enter, and it will show what exactly vulnerabilities do we have. So it can show you some severity is high, and there are uh, some vulnerabilities in our, like, in our directory that we have right now. And we can also scan the image, so Docker image that we built. So Privy image, and then we would be mentioning the Docker image that we built. So let me just fetch the image first. I actually removed it, but yeah, I can show you the SonarQube scan. SonarQube image scan by typing Trivy image and then followed with the image number, image ID. As you can see, everything is scanning right now, and it will, like, tell us what exactly do we have in here. So let's see. Uh-oh. Should have not used that. Yeah, that's okay. There's some error while scanning this. If I would have just like showed a simple scanning for the Netflix image that we created, that would have been better, but I actually deleted it so that we can automate the entire process. But yeah, I can show this to you later when we scan our Docker images using our pipeline, which we would be doing out here. As you can see, there's the SonarQube analysis that we would be doing, and then later on, we also would be doing the Trivy scan. As you can see, this is a file system scan, and then we are copying the output into the Trivy fs.txt, and then we are using the scan Trivy image in order to scan the Docker image. I'll show you later on how this would be working. So where exactly were we? We are able to access our Sonar server. The just enter the password as admin. Mm, so we are successfully entered out here. I would also show you some how to generate the API token. This is I'm doing it beforehand. So we would be accessing our SonarQube server via Jenkins. So I'm creating it's a like token API token in order to access Jenkins. So this is our token which we would be using in our Jenkins pipeline. But before that, we actually need to install Jenkins. So let's do that first. So let me go here and let me just show in order to download Jenkins, it requires Java. So we have a script over here which downloads Java, GRE OpenJDK17, and then this is a command, this is a script for installing Jenkins and also starting and not boot up as a daemon and a service which spins up automatically using the systemctl command. And then we just copy this and paste it and enter. So this would download everything for us. So as you can see, everything has been installed, and now we can access our Jenkins server on port 8080. So let me just go out here, just copy the public IP and access it on port 8080. Here you go. So initial admin password, just copy this, go to your terminal, use sudo cat in order to like give the super user permission, and then we fetch the password, initial admin password, copy this, um, we just paste it over here, install the plugins. That would take a little bit of time, and by the time this downloads, we would then be actually configuring some plugins into our Jenkins system so that we can use those plugins in order to make some changes to whatever we want to do with our software delivery lifecycle. It provides us connection to talk to the APIs of the services that we would be using. So, example, SonarQube. So there is a provider plugin called SonarQube Scanner, and we can also use Java. We would be using Node. So everything that we would be using, we would be actually installing a plugin for that, and then using that plugin, we would also be configuring into the global configuration about uh, like what exactly binaries do we would really want in order to use, and I'll just show that to you later. Save and finish, start using Jenkins. I'm using the administrator as it is. So let's set up some plugins. Go to available plugins. So there are certain plugins that I would be mentioning in my repository. And as you can see out here, we initially just scanned SonarQube scanner. Okay. And then Eclipse for Java. Yeah, there it is. And then we would be downloading Node.js, and there was one more, which we would be using in a pipeline, that is Docker Commons, Docker pipeline, builds chips, and Docker API. There was one more. Did I install it already? Docker API. There you go. So install all these tools, the plugins, and once it is configured, if it asks us to restart Jenkins, then you can do that. If it doesn't ask us, then it's not really required, and you can use that. Yeah, so everything is done. So let's get back to manage warning. So after we install all the plugins, there was one more, which is email extension plugin. So I'll just download that as well. That's the one, right? Install. And once we install that, we would be configuring some credentials. So how can you do that? You can reach out to the credentials out here. But before that, hold up. Before setting the credentials, I need to configure the tools that I have downloaded. So we would be going to do that via tools and just search for JDK. Oh, sorry, the Eclipse terminal. First, you would be installing Node.js. Node.js would be this should actually match what we are mentioning into our pipeline. So node 16, that is the name. We would just copy this and we would be pasting out here, and the version would be 16.2.00, and that is the one that we will be using. And so for JDK, we would be copying the JDK17. Just copy this and we would be installing Java from adoption or adoptium.net, and the version would be JDK 17 8.1.1. So just save it, and once we have configured our Node.js and Java, we would be setting up some credentials. So let's go here, just click on systems, global credential, add credential, and we would be using a secret text. Secret ID would be Sonar token. which we can refer it from here from our pipeline. This token would be used in order to access the SSH server. Oh, sorry, SonarQube server. And the secret would be fetched from here, the token that we generated. Just copy the token and paste it out here. Create. So now, as you can see, we have not halfway through, but yeah, 33% of it is complete. So let me get back to you. And over here, we have figured the credentials for SonarQube, saved it, and now we can actually use this pipeline script in order to run our pipeline partially. And let's see whether it runs or not. So how we would be doing that, we would be configuring our pipeline uh, by this Netflix pipeline. And then we would be just pasting the script out here and save. So before building this job, I would actually configure SonarQube server into my global configuration. And then that's the part that I forgot. So you can just scan for Sonar's SO, and then you would be landing onto the page where you can find Sonar Scanner. And then you also have to configure the Sonar Scanner as a tool because you have to mention the libraries or the binaries which Sonar Scanner would be using in order to scan our static code. Like so, basically, we configure the Sonar Scanner as well, and we install it from Maven Central, and the version could be anything, and then we search out for OWASP for the dependency. So you can actually search for dependency, which would be at bottom. So yeah, once you do that, you have to mention DP check because that's the keyword which we have used in our pipeline. So yeah, let me just show it to you in our Jenkins file. I'll just go down. And here, as you can see, in OWASP file scan, we have DP check. So there is one more addition onto it. So currently in the video, this is not covered, but I added an API token in order to make the dependency check fast because it OWASP actually needs an API token. So the process for generating the API token, I would explain that, and it's mentioned in the README file though. But let's see and let's start to build our pipeline again. So as you can see, the build number 14 was unsuccessful. After everything was done, we first checked out the code from Git, and then we performed SonarQube analysis, then the quality gate, and then we installed the dependencies, which was, but yeah, let me just show my SonarQube scanner as well. So as you can see out here, everything is passed. So Netflix, and inside Netflix, you can just check out for issues. So here you go, and then you can just go out for major, and these are the basic issues that were present inside our Sonar scanner, but these were minor, so it's not really a huge problem, and this is the concern for security. And as you can see out here, the should be replaced with an uppercase AS. So that was it. And then we went to OWSP file scan. We installed the dependencies using npm install, and then we also did the OWSP file system scan, and then we did Trivy file system scan, and we then built the Docker image using Docker, and then we did the image scanning using Trivy scan. And then while we were pushing it to our ECR repository, we had an error. So let's see and check out what the error is. So it says AWS not found. So basically, in order to let Jenkins access the ECR repository, we have to install AWS CLI into our Jenkins server. So how can you do that? I'll just show it to you. You can just copy this script. I'll just mention this entire script in the README file, and you can use the same script in order to install the AWS. So let's do it. Let's just go like download the binaries first, the zip file, and then we unzip it. All right, I'll just like copy everything right there and then just copy this. So sudo that is used for running the script, sudo.aws install, and then we can fetch the version. It says for AWS informed it can be installed with. Okay, so you can do sudo apt install AWS CLI. Just copy this and then you can paste it into your terminal, enter, and voila, yes. Just waiting for the deployment. So once this is deployed, you can check the version. Okay. 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 Yeah, perfect. So yeah, once we have installed the AWS CLI, you can check out the version. Here you can see AWS is installed. So now we would be configuring our AWS account using our access ID and the secret key that we have. So you know how to generate that, right? So like we have to generate, we have to make a user, and then in that user, we can actually generate an access key, which would be given to us by AWS, and then we can use the access key ID and the secret key in order to configure our AWS account. I'll just show it to you. Just give me a second. Manage console, and then we go out for IAM users. And I already have users, so I'll just show it to you, security credentials. And then as you can see, access keys, I have already generated 2 access keys, which I am using right now. And you can also create a new access key. And right now, you can't see my secret ID, right? But once you generate the access key, AWS will be prompting you with a secret access key. So you have to save that. And right now we would configure AWS within our Jenkins server. So the command was, yeah, now found that was it. So let's go out and make some changes into our server. We did that. And now after configuring, because I skipped the part where I configured, because I don't really want to show the secret access key and the access ID. So now let's try to build the pipeline again. And once the pipeline was finished, as you can see, every stage was passed, and you can see the SonarQube was done, the dependency check was done by OWASP, and then, yep, everything was passed. I'll just show you the exact steps which actually happened in the console pipeline, or the overview. Console output can be seen out here. I'll just show the pipeline overview. And as you can see, again, we went through the entire stages without any problem, and the image was pushed to ECR. And let's go to our AWS configure, access key, everything. So I just want to show that to you. And this, if you want to access, like configure it, these would be the prompts which would be given to you, and you have to paste the security access key and the secret access key over there. And then we are out here, the image is pushed. So this is my repository, and inside the repository, as you can see, there is an image tag with 16. So 16 is the build number that we have within our pipeline. So as you can see, we have an image which was just pushed on 17th of December at 2, as you can see out here in the timings. And yep, that was one part of it. And how it really works is the repository is the image name, okay, and the initial thing is the account ID, and then we have the URL for our ECR repo, which is in US East 1, and then the Amazon AWS.com, and that's how the basically the convention for storing your image in AWS works in ECR. So I also made some changes into the configuration file in Terraform. So I actually added two more ports into it, and I added 3000 for Grafana and then 9000 for Prometheus and 9090. Sorry about that. Yeah, and then I also launched. I also added a configuration for launching a monitoring server. So that's it would be easier for you to launch everything at once. So I can just show the EC2 instances which were launched using the Terraform script that I changed. As you can see, the instances are 6. And due to some money reasons, I have actually stopped the monitoring server. But monitoring server and the Jenkins server are the ones which were deployed via my Terraform script. So, yep, that's how it went. And yeah, so as you can see, out here. So the next part for our project would be the monitoring. The monitoring phase, basically what we do is we install Prometheus for monitoring the resources that we want to monitor, and then we install Grafana in order to view the matrix which has been fetched by Prometheus into a more human readable form in dashboards, and then we also install Node Exporter. Node Exporter is basically used in order to scrape the matrix in order to like fetch the data from the servers that you want to monitor the performance for. And once you install Node Exporter into it, it can fetch the data and then convert it into a matrix form, which then can be used by Prometheus in order to scrape the matrix using targets in the prometheus.yaml file. So I will describing everything to you in detail as we move along. So there was actually an accident. I created the entire video where I deployed the monitoring server perfectly, but by accident I actually deleted it. So I'll show you everything again, but I'll probably be skipping the parts, some of the parts. So initially installation is pretty easy, and what we do is we create a dedicated Linux user for Prometheus and download the Prometheus file, and then we extract the Prometheus file, move them and create it into the directories, the respective directories, as you can see, and then we change the ownership for the directories. Then we actually create a systemd unit configuration file. So basically what happens when we create this file is like we tell our system to spin up Prometheus whenever the system starts. So as you can see out here, the description for the service is Prometheus, and whenever the network is online, that is our machine is online, that this Prometheus service would be spinned up, and the service can be used by the Prometheus user and also like rest of the things that we have mentioned out here, and it runs on port 9090. So after doing that, we have to enable the Prometheus service and then start the server, and then once you do that, you will end up onto you can check the status for Prometheus using the git status command, and as you can see, everything is running perfectly fine out here. And then we install the node exporter. Same procedures, same steps. We create the system user for node exporter, and then we download the node exporter, and then we move it untar like unzip the file, and then we just move it to the respective folders in binaries to the respective places, and then we again make a service file in order to spin up node exporter whenever the machine starts, okay, at boot time. And then once you do enabling and then starting the node exporter, you can get the like status by copying this command, and you would also be getting this status which would be active and running. And then once you do that, you have to configure the Prometheus plugin. Prometheus YAML file. So how can you do that? You have to go, you have to first reach out where exactly was this file stored. So this file is stored in etc Prometheus uh, hyphen Prometheus YAML. So you can just copy this, and then you can do sudo nano, and then open the file. So what I did was, initially there wasn't any jobs which was mentioning node exporter and Jenkins. So I just copied this job from here. I just copied these and I mentioned, so since the node exporter is running on the same machine, I mentioned it localhost, and then the Jenkins servers was running on different IP. So you have to mention your IP of the server where Jenkins is running. And then once I made the changes, everything, this is the server that my Jenkins is running on, and then you provide a port, and then you just go back, save, and then once you do that, you can check the configuration for the file that you just edited by this command, and it would be showing you a success if it is perfectly syntactically perfect. And then you do curl reload so that Prometheus can update the targets. So I already did that, and once you do that, uh, let me just show it to you. So yeah, once that is done, now we can refresh it. So you have to go to status and then targets, and then initially only this thing would be showing up. And then once you add the new targets, Node Exporter and Jenkins would be showing. So now once everything is set up, we have to configure Grafana so that we can have a good overview with using dashboards in order to view these. Okay, and how do we install Grafana? We just we just install it, install the binary dependencies, and then we add the GPG key for Grafana. And then once you do that, we can add the repository for Grafana stable releases so that it can refer that. And then once we do that, we update and install Grafana. And then again, if we want to automatically start Grafana after reboot, we do enable it using system CTL commands. And then once that is done, you can again check the status using this command for system CTL status Grafana, and I can show it to you out here. It has already been running, so perfectly fine. So now we can reach out to our Grafana dashboard or URL using the IP, and then providing 3000 onto it. And then once you do that, there would be a welcome home page like this. So what we have to do first of all is we have to integrate our data source. So what is our data source right now? Prometheus would be using Grafana would be using Prometheus as a data source to fetch the information or the matrix from, and then it would be using some dashboard in order to show us. So how can we do that? We have to go on connections, and then you have to go on data source, and then you have to click on uh, Prometheus like this. I already have one connection, so I won't be adding it. And once you add Prometheus, so let me just show it first of all. So you can just type name, and then the URL is localhost 1990 only. And then once everything's done, you can just do save and test. So I'll simply go back. After you do save and test, you can go to dashboards. And then as you can see right now, I have dashboards, some certain dashboards already present, but initially for you, everything would be new. So what you would be doing is you would be importing a dashboard. So how can you import a dashboard? What is it? So basically there are some uh, what should I say? There are some developers who created a dashboard which you can directly use. So as I can show to you, we can search for Jenkins Grafana dashboard, and then we can just open this link. And if we want to use this dashboard, we can just copy the ID, and then we can paste it into our Grafana URL. So Control V. So 9964 is the ID, and then you do load. So it would take you to a page where you would be having this type of dashboard. So this dashboard is basically monitoring my EC2 instance. And yeah, right now I haven't done anything yet with my EC2 instance. So let me just show, where's my, hell? Okay, just give me. So as you can see out here, once we access our Jenkins pipeline, you can see we were successfully able to deploy our pipeline, and you can see the console output. I can just show you the overview first of all. So we did install the tools, necessary tools. That was npm node and Java. And then we cleaned the workspace. Then we check out to our GitHub repository. And then we did the SonarQube analysis, the static SonarQube analysis, right? And then we did quality gate check. And once everything was approved, we moved to the next stage, which was installing the dependency for our application, which was npm install. And then we did OWASP Dependency-Check in order to check the dependency vulnerabilities that might exist within our pipeline or the dependencies we just installed using npm install. And then we also did Trivy file scan in order to scan the file system in our inside the environment that we have. And then we build the Docker image using basic Docker commands. As you can see, it referred my Docker image over here. Uh, this was a Docker image, and that's what it referred. And then Jenkins, yeah. And then we were able to do the Trivy scan once we built the Docker image. And then we were able to push the image onto our ECR repository. I can show the repo to you. Just give me a second. ECR. So as you can see, the build number was 3. So we should be having an image with the build number 3. Let's see, do we have it over here? Yeah, we have it. So it was just pushed like some time ago, and then everything was done. So basically, post action was just clearing up everything and clearing the Docker images that were created. So this basically summarizes our CI part, and then we would be using EKS-CTL in order to deploy the EKS cluster and AWS CLI in order to configure the AWS account that we have so that our monitoring server can deploy the EKS cluster easily. And then once we deploy the EKS cluster, we would be installing ArgoCD and Node Exporter using Helm charts. So ArgoCD is basically a GitOps tool that is used for deploying our application, which monitors any changes happening onto our repository. So ArgoCD would be helping us to deploy the application, and then Node Exporter basically would help us to fetch the resource utilization or whatever monitoring that you want to do onto your resource, onto your EKS cluster. So Node Exporter would be fetching the information from the cluster, and then it would be used in order to scrape the matrix into by mentioning the target of Prometheus into our prometheus.yaml file. So yeah, so that's how it's going to be. So before we do that, I would be configuring Prometheus. I think I didn't show that to you earlier, but I also I installed Prometheus. Let me just show it to you. Prometheus metric plugin was installed, and then I simply installed it, and then I went to system, do Control F, metric. Sorry, just go for Prometheus, and here you would be landing onto this default configuration which would be already done for you, so you don't have to make any changes to save it. Okay, and once everything is done, so now Jenkins can forward the necessary matrix. Oh, we actually did that. So yeah, in this stage, when we were actually mentioning the Jenkins target, as you can see out here, just give me a sec. We edit the Prometheus YAML file, right? So here, as you can see, in order to scrape the matrix from Jenkins, so we had to mention the target, and in order to like scrape the matrix inside Jenkins, we had to install a plugin, right? So that's what we are doing right now. And if I go back over here and I go Prometheus, this is the matrix which is being generated like from my node exporter or the plugin, and then this is being fetched by Prometheus scraper, and then we are using the Grafana in order to view the dashboard out here. So this one is for Jenkins, and then there is one more for Node, for the node that we are running our monitoring system upon, and this is information for that. So this was pretty much it. And let me show you how can we deploy EKS cluster from our monitoring server now. So just give me a second. So what we would be doing is we would be referring our repository or our README file, and I can show it to you out here. So there are certain steps that we have to do. First of all, we have to install AWS CLI. You can use this script in order to just copy it, just like download the AWS CLI. Once you do that, you can just, I already ran the command, sorry about that, but you can just type AWS version. And once you type AWS version, you can get the version. And once that is done, you can install AWS CTL from these commands. So basically, you just copy, you just call the this Prometheus, and then we move, and also we unzip it, and then we move Prometheus to the required binaries, and then we can view the EKCTL version, which is out here. So basically I just launched the command for running the EKS cluster, but basically we are using EKS because we have it installed in it. So you can see the version. So it would be giving you an output for with the version name. And then you also need to install kubectl. So now why do we need kubectl? Kubectl is basically it is used to interact to our EKS cluster, and this is a command line tool which reaches out to the Kube API server, and it helps us talk to the like Kubernetes cluster using the command. So this is the command line tool for interacting with Kubernetes. So how can you download that? You can download that using curl command, and then once you do that, you can move the executables out here into the required binaries, and then you can get the version. And now in order to deploy the EKS cluster, you can just copy this command, EKSCTL cluster name. This is providing the cluster name would be demo EKS, and the region would be US East 1, and the node group would be my node group, and then the type would be T3 small, and then the managed means like a EKS would be automatically managing the nodes, and there would be two nodes particularly within this cluster. And it's going to take good amount of time in order to launch the cluster. As you can see, it's going to take like 15 minutes approximately, and once everything is done, then we have to install Helm chart into it, and then install ArgoCD and Node exporter using Helm chart, and then we would updating our Prometheus.yaml file in order to add a new target to fetch the matrix from our EKS cluster. So let's wait until then. So by the time guys our cluster is being deployed, I can also show you the email notification part. So what we have to do is first we have to go back and go for manage Jenkins. We installed a plugin called SMTP, right? So we just reach out down here in our configuration, and this is our email notification. So how we do this is, first of all, you have to create an API token for your app token from Google. So how do you do that? You first have to enable the two-step verification. So I think this is turned on. So yeah, once you turn on the two-step verification, perfecto, you can go for app password. So basically this gives you an password. If you want to access your Gmail account, you can't just access it using username and password. So you have to create a special API token for it. So we would be saying Jenkins, let's create, copy this token, and reach out to your Jenkins pipeline. So the SMTP server would be SMTP devsecOps.gmail.com, and then email would be your email, which is HRITJES, 746 at gmail.com. So this is my email ID, and then you also do advance. Field should be followed by what happened. So this is not actually a big deal because we have specified that uh, we have added at gmail.com. So after that, you go advanced, you go SMTP authentication. The username would be same. Then you enter the password, which you copied from the Google. Just paste it over here. And then the port would be 465. Yeah. And then I think test configuration by sending the email. So let's just test it. It was sent successfully. So let's refresh it and see whether we received the notification or not. Well, nothing yet. That's weird. Oh yeah, the reason why we didn't receive the email was because of this. I forgot to add email. So we save it. Oh, just show it to you. The test config. So let's test the email again. 43746@gmail.com. Test the config. Hopefully, yeah, perfect. We received the email. So now this has been successfully configured, but we also have to configure this email extension. So the SMTP server would be same, which would be smtp.gmail.com, and then port would be 465, and then the credentials. So we have to save the credentials out here. So once we do the configuration for this, we also have to configure our extended email notification. So again, we have to mention the server and then the port. And here I added a credential. You can also add a credential in Jenkins with username and password. Username would be your email ID and the password would be your classic password that you use. And then select use SSL, and also select the default type as HTML text, and then go down, and then you'll find default triggers always and on failure. So everything is sorted now. So let's just save it. And then I also added a configuration block into my pipeline, which is basically used in order to push the notification, uh, like in order to provide or send an email to my email ID, that would be attached, that would be having the file system scan and the Trivy image scan documents attached. And let's see whether it runs successfully or not. So let's just copy this and paste it down here. Just copy this and just paste it in our pipeline script and just save it. And let's try to build the pipeline again. And by the time I think the EKS cluster has been deployed, so we can further do our other processes. Now, since the EKS cluster is deployed, we can fetch the cluster details using the EKSCTL get cluster command. So just copy this and paste it over here. And it will. Oh yeah, the cluster name is different. The cluster name has like one more E. So as you can see, here is our cluster, and now we have to add our like cube. We have to update the cube config file so that we can access this cluster using kubectl. So we will just copy the command and go out here and then just paste it. No way, no way. Or we can just copy this command. See, and then just paste it down here. And this will be for EKSSS. Added new context. Now, yeah, we can access our cluster using kubectl. So everything is done. Now we will be installing ArgoCD using these follows like using these commands. And first, we would be creating a namespace for ArgoCD. Let's just copy that and create a namespace with the name ArgoCD. And then we download ArgoCD using the Helm charts that we have. So just copy this and just paste it over here. And once this is done, this basically deploys ArgoCD onto our cluster. And then once this is done, we have to basically expose the ArgoCD using the load balancer because we are deploying it on cloud. So we can use the expose the service type as node balancer so that we can just access it using the load balancer that which would be provided to us. So the service has been updated and now you can access the ArgoCD on the port number which I would be mentioning to you, but basically you don't need a port number since we just deployed the service using uh, Elastic Load Balancer. We can access ArgoCD using Elastic Load Balancer. So let's just paste the initial admin password for that. So this is the password that we would be using. We would also be getting the service kubectl get service -n ArgoCD. This was give us the entire services which are present in our ArgoCD cluster. You can just copy this and open it into your browser. Just follow. Oh, let me just check it out. So basically what happens is this is and connection is not secure. Okay, so we will just access it anyway. Let's just open it into a different browser. Advanced access anyway. So yeah, now here you can access the ArgoCD. That was Brave browser, so it had some more, what should I say, filtration in order to access the private network. And then we would be copying this password that we used, that we fetched using the command. So Ubuntu, yeah, to here, just copy this. And then you just paste it out here and enter. So this is our ArgoCD and how we can like connect our repository with ArgoCD is go to repository, connect repo. Via GitHub, project name would be default. I mean, we can just skip the step and straight away just deploy application with this. Netflix project name would be default, and then manual automatic, and then auto create namespace. The URL would be the URL for our GitHub. That would be copy the URL out here, paste it, and then the path to our kubectl deployment. Cube deployment file would be this. Just copy this and then paste it out here. You don't have to copy deployment, and perfecto. Cluster would be perfect. Namespace could be my nm, my, and then we just go and create it. So what does it say? Lowercase, okay. So this is done now, and now this would be syncing our application. So what do we have out here? It's showing out of sync and app filter is missing. So we can see the events happening right now. Everything has been, the resource has been updated. Cool, we're good with that. So application resource not found in the cluster deployment. Yeah, okay. And what we would do is we would actually make some changes into our deployment file now. So let's go ahead and just make a change. We will just do this, create the change, commit, and let's see whether ArgoCD was able to fetch it or not. So before we actually launch our application using ArgoCD, there was some error out here because it was out of sync. So what does it say? Resource not found in the cluster. What do we have out here in our repository is like we have a node service, but yeah, it's not present because we haven't uh, deployed node exporter onto our EKS cluster. So we have to do that as well. So in order to do that, we would be following the required processes. So initially, we have to add Prometheus community Helm chart repository in order to install Prometheus using Helm chart. So let's go and do it out here. First, we install. So in order to download Helm, we can just do a Google search. Go, there's installing Helm. So you can download it from here, from script. We will just download it from the script. So just copy the script. Just do it step by step. Control C, paste, done. Be providing permission, done. Now we would be starting our script for installing the Helm. So Helm has been successfully installed, and now we would be installing Prometheus by Helm charts. Prometheus has been added. Now we need to create a namespace for the node exporter so that we can deploy node exporter in there. using Helm chart again. So we created the namespace and now install the node exporter using Helm chart. There you go. Installation Kubernetes cluster and expected API version. Authentication alpha. Okay, let me just have a look at it. Why is there an error? So by the time we resolve the error for Node Exporter and installing Node Exporter using Helm, I'll probably show you the application that I am deploying using ArgoCD. So let's go, and as you can see out here, it has been successfully deployed. So I looked into it. So the namespace that our application needs to be running is should be default. So initially I just had my namespace, but uh, to be launched. It's supposed to be launched in namespace default. So as you can see out here, this is a Netflix application that is present, and we can have a connection to it using the load balancer. So let me just give and show it to you how exactly can we fetch it. You can see there are services created and everything is out here. These are the pods which are running our application on. So hold up. You can reach out to your AWS account and get to load balancers. ELB. I think it should be here only. Load balancers. Okay. So there should be two load balancers deployed. And let's see which one is it. Did we launch the application using load balancer type? Oh, not really. I think so. We used node port. Yeah. So the node port on which our application is running is. So as you can see, I have made some changes and changed the service type from node port to load balancer. And let's see whether our ArgoCD detects this change and can it deploy a balancer into our AWS account or not. So let's see, reach out to the ArgoCD. And as you can see, app health, this is actually processing now. So as you can see out here, things are being updated. I'll show you the events, scaling set replica, and here you can see there would be some changes which would be happening and launching pretty soon. So now service is also changing. So now, as you can see, our application has been deployed and the sync has been done. Application health is processing right now. But if I reach out to my AWS account and show you, there is one more load balancer now. So if we have a look at it, which was the recent one, this was the recent one. So if we just click on it and we copy the DNS, we would be able to access our application using this load balancer. Let's show it to you on Google Chrome. Not secure. Okay. So our application was running on port 80. So as you can see, the image has been updated and we made some changes in our service.yaml, right? So we just change it into the load balancer type and we fetch the load balancer DNS. We just copy it and then we paste it in our Chrome browser, paste it, and we try to access the application on port 80 because that's where it is running, and voila, you can see the application is perfectly running fine, and you can see everything is working as required. There you go. So that was the continuous delivery part, which consisted of GitOps and using ArgoCD in order to deploy our application. You can see there are two pods created for it, and that's what our main script said to deploy in our deployment file. There were two replicas, and you can access any of those replicas using ArgoCD. So this was the one that we accessed earlier, and we can also use this one. So what Kubernetes EKS does is it also provides us load balancing onto the pods, and everything is managed by EKS. So if there is any traffic which EKS wants to divert, it uses load balancing internally within the clusters in order to divert the traffic. So that was it. And we also had some email notification set up, right? So let's check whether we received the email or not. So let's refresh it. Yeah, nothing has been done yet because we didn't run the pipeline. So right now it's running. So let's see if we get any notification or not. Dependency check has been done. It's running still. So once the pipeline finishes, I'll give you an update for the same. So as you can see, the pipeline has been successfully completed, and an email has been sent to Ritix 437436 at Gmail, and our application is also deployed out here. So this would be it, and I would be concluding my project out here. And there was some few tweaks or like some additional detail that I would be updating into my README file regarding the node exporter. So there is one thing that we haven't finished yet, so which was configuring node exporter onto our EKS cluster. There has been some issue configuring installing node exporter using Helm. So I'll update you guys for the same, but the entire thing is same. Node exporter would be fetching the details, the metrics from the cluster, and then we would be adding one more target into our Prometheus file. And then, yeah, we would be able to watch everything over here in Grafana. So that would be it. So I hope you guys liked it, and see you guys again in future. Thanks.